Assalamu alaikum, guys. It's Dr. Shafat Khan back on your screen. I hope you're doing well. In this lecture, I'm going to teach you the mole concept and specifically the concept of limiting reactant. Okay, topic that 90% of the students get wrong every year. Very, very important topic. Okay, please pay attention as we go along this topic. At the end of this lecture, concept of limiting reactant would be crystal clear, inshallah. Let's get started. We need to first revisit the mole concept. Okay, I hope you guys do remember the mole concept. Mole in chemistry basically is a physical quantity, but mole simply means a specific amount of a substance, right? Amount of a substance which contains a specific number of particles, 6.02 times 10 to the power of 23 particles, the Avogadro number of particles. That's the amount which is called 1 mole. And that's basically the definition of a mole. Okay? There are other formulas of moles that you need to know. For example, mole is equals to, based on this formula, it's the number of particles divided by the Avogadro's number. Avogadro's number is 6.02 times 10 to the power of 23. That's the first formula for calculation of moles. The second formula for calculation of moles. Second formula is in terms of mass in grams. Okay, so mole equals given mass in grams divided by given mass in grams divided by molar mass. Okay, two basic formulas enough for the lecture. Now let's talk about limiting reactant. Okay, let's define limiting reactant. As the name suggests, it's a limiting reactant, right? It's not a product. So that means it has to be on the reactant side. It's basically the reactant which is in the least quantity according to the ratio given in the stoichiometric balanced equation. Okay, we write it down. The reactant in the least quantity that is fully used up and hence controls the quantity of the product. Okay, the higher the limiting reactant, the faster the product. Any substance that is completely used up will be considered limiting reactant. Let's see how we calculate limiting reactant. Now, let's assume we have some two reactants. Let's say A reacting with B. Produce C and D. Let's say we need 2 moles of A and 1 mole of B to give you C and D. Okay, this is the complete balance equation. Once you look at the balance equation, let's say there's some data given in the question. For example, A has a mass of 2 grams and B has a mass of 4 grams. Okay. The AR of A is, let's say, 2 and the AR of B is also 4. Okay. So based on this, now how will you know which of these two is the limiting reactant? Now we cannot judge this based only on the masses, okay? We need to convert these two into their moles. So first we need to find out the moles of A. which is mass or molar mass, so 2 over 2, which is 1. Then we need to find the moles of B, which is again mass or molar mass, so 4 over 4, so that's also 1. This means A and B are present in a ratio of 1:1 according to this mass which is given. Now, if it is present in a ratio of 1:1, according to the equation, for every 2 moles of A, according to stoichiometric ratio, 1 mole of B is required, right? The ratio should be 2:1, meaning for each B, for one B, there should be twice of A, correct? But do we have twice of A? No, we don't. We have half of A, and we only have 1. So 1 is in the quantity lesser than the quantity expected by the stoichiometric equation. Hence, this A is the limiting reactant. Okay? A is the limiting reactant because it will control the amount of the product and it will be used up first. So if A is the limiting reactant, then B by default has to be the reactant in excess. Okay? That's the concept of limiting reactant. Now I have a bunch of practice questions for you guys. You can just use them. This is question number 3. What is the definition of a limiting reactant? So try answering it. Okay. The answer is A, the reactant that is used up first and prevents more products from being made. Okay. And question number 4. And 1 mole of ammonia and 1 mole of oxygen are mixed, then the number of molecules of NO formed will be. Now, according to the equation, the ratio should be 4:5, right? For each 4 moles of ammonia, 5 moles of oxygen are required. But the ratio they gave us was 1:1. Okay. This means for 4 moles of ammonia, you should have 4 moles of oxygen, correct? You have 5, so that means oxygen is in excess. What will be the limiting reactant? It would be ammonia. Okay. Once you found ammonia to be the limiting reactant, you can use it to get the product of NO. And because their mole ratio is 4:4, meaning 1:1, whatever the moles of ammonia are will be the moles of NO. So moles of NO should be the same as that of for every 4 moles, you need 5. For every 1 mole of ammonia, you will be needing, let's assume it's X. Cross multiply, get the answer. This is going to become 4X plus 5 and 0.8. Okay. 0.8 moles of oxygen would be required. 0.8 moles of oxygen will be used up. You have 1 mole of ammonia. The oxygen is the limiting reactant, not ammonia actually. Four ammonia, 5 oxygens. And 1 mole of ammonia. So 4 moles of oxygen are required, not 5. 1 mole. Oh, okay. Oxygen is in excess. 1 mole, 0.8 moles of oxygen are required. If you give this question, this seems to have some issue because when you have 4 ammonia molecules giving rise to 4NO, and you have decided that, yeah, ammonia is the limiting reactant, mole ratio is 1 is to 0.8. For each 1 mole of ammonia, you need 0.8 moles of oxygen. I think there's a mistake here. Wait, this cannot be 0.8. Okay, so question number 5 is 10 grams of marble are added to 15 grams of dilute hydrochloric acid. Product formed is calcium chloride, water, and carbon dioxide. Which of the following is true? So you have certain masses of marble and dilute hydrochloric acid. The first step is always to make a balanced stoichiometric equation. The calcium carbonate, when reacts with hydrochloric acid, it's going to produce calcium chloride, carbon dioxide, and water. Okay? You need to balance this equation as well. The 2 moles of hydrochloric acid are used. And I think it's balanced. Yeah, it's balanced. Okay, then they have given you masses, right? Always have to compare it based on the stoichiometric mole ratio. In this case, the mole ratio is 1 is to 2 between calcium carbonate and hydrochloric acid, right? It's 1 is to 2. Now you need to calculate the moles of calcium carbonate and dilute hydrochloric acid as given in the question. Let's calculate the moles. The formula is mass over MR. For calcium carbonate, it's going to be 10 divided by 100, which is the MR of calcium carbonate. This is going to become 0.1 mole calcium carbonate. Now remember, 0.1, this is 1 is to 2, right? So for 0.1, there should be at least 0.2 moles according to the ratio. Okay? 0.2 moles. If the moles now that we have are more than 0.2, then that would mean HCl is in excess. Okay? But if the moles are less than 0.2, then that would mean HCl is the limiting reactant. We need to first find the moles of HCl. Okay? Again, use the same formula, mass over MR. Let's calculate this. This turns out to be 0.4. Or 0.4 is more than the expected ratio, right? It's more than whatever we expected according to the stoichiometric ratio. That means HCl is the one which is in excess. Calcium carbonate is the limiting reactant. So hydrochloric acid is not the limiting reactant, it's in excess. Yep, it's excess, and calcium carbonate is also not excess, it's the limiting reactant. So only B. Hydrochloric acid is the excess. Okay. And then this question 7 you can take as your homework. Okay, edit the solution is also given down there. So just to summarize, we revised the concept of mole and limiting reactant. The formula for calculation of moles are mass over mr, or number of particles in Avogadro's number of particles divided by Avogadro's number, okay, or mass measured in grams over mr. Then we studied about limiting reactants, quantities, the reactants in the least quantity that are used up first, and they will control the quantity of the product. Okay, the steps are very simple. You first need to find out, make a balanced equation, then find the mole ratio according to the equation, then calculate moles of both the reactants, then finally compare against the mole ratio given in the equation. If any component is more or less than that mole ratio, then that would determine if it's in excess or limiting reactant. Okay, if it's more than the quantity given, if it's more than the quantity given according to the equation, then that would mean it's going to be in excess, as we did over here, the last step. Like, this is the most important step, which we calculated over here. Okay, with hydrochloric acid. We figured out how much of hydrochloric acid must be required according to the stoichiometric balancing. Okay, and then we calculate the actual moles of hydrochloric acid and compare them against the expected. If it's more than the expected, then that would mean it's in excess. Okay, right. So if you need more stuff, like you need the entire lesson of moles, or if you need notes, just DM me the word excess and you'll be given them. And you can follow me on Insta, Facebook, WhatsApp, TikTok, wherever you can see it, YouTube. Okay. So that's it for today. See you again in the next video with something more important and informative. Thank you.